So this one's all about system of equations, and there's 3 ways to solve a system of equations, okay? One way, the first way we're going to talk about is graphing. The other ones are substitution and elimination. And that's all we're doing today, just reviewing systems of equations. All right, so let's go ahead and talk about the graphing method first. The graphing method is to graph the lines and find where they cross, okay? So I'm going to start with this one. I'll color code it green. So when you're graphing a linear function, this is your y-intercept. That's where you start first. Is that your y-intercept? So I'm going to start at 2 on the y-axis. This is my slope. So I'm going to go down 2 over 1. Down 2, right 1. So starting from here, down 2, right 1 puts me right there. And then you go ahead. And by the way, you could just connect the dots at this point if you wanted to, but when you're doing a system of equations, you want to be as precise as possible. So instead of just connecting the dots here, I would just keep using the slope over and over, right? So down 2, right 1, down 2, right 1, down 2, right 1, and then work backwards. Okay? And that way you have a bunch of dots, and we'll go ahead and connect them all there. All right, let's do the next one. So where am I going to start for this one? At -3. So let's put a dot at -3. And I'm going to go, it's negative again. So when your slope is negative, you go down, but we always go to the right. So it's, no, don't talk on the phone in class while I'm teaching, booger. All right, so say goodbye. You can say one more word to that per se. Actually, if you say, Mr. Bailey said I can't talk on the phone, I gotta go now. All right, so down 1, right 3. So starting from here, down 1, right 3. And once again, just keep the pattern up. Working backwards, it would be like that. Down 1, right 3. Yep. And then, where do they cross? Okay, there's my answer. So I'm going to draw an arrow there. I'm going to say my answer then is 3, -4. Questions? Preguntas? Sí, señor. Can you turn off the lights of the board? It's like more. Hi, Orlando. What's up? Let's do another one here. You know, I'm not exactly here. I want to make a slight change to number 3, you guys. So, would you guys do me a favor and change this 5? Change this 5 into a 1, please. Change the 5 on number 3 to a 1. We can't erase it. Okay, so let's begin. I'm going to do the one on top here first. Where am I going to start? 3. And I'm going to go down 1 across 4. Now what I really am kind of disappointed in is every example that I'm doing right now has a negative slope, so I keep going down. But you guys need to know that when it's a positive slope, you go up, right? So just remember that. So down 1, right 4, looks like that. And I'm going to connect my dots. So there's that one. That's where the line would go. Oops. So, next one, I'm going to start at -1. Start at -1. I'm going to go down 1, right 4. Down 1, right 4. Same thing over this way, just opposite direction. That's right. These are parallel lines. You guys haven't had geometry yet, have you? Some of you have. This is the symbol for parallel in geometry. You don't have to worry about that. But what does that mean when you have parallel lines? You're trying to solve a system. Which means there is no solution. No solution. All right, so I'm going to let you guys do 2 and 4.
Well, that was number 3. How about number 5?
2 and 4.
Do 2 and 4, please. I'll give you guys like a couple minutes. Go.
Oh.
2 and 4 on your worksheet. New strategy, guys. Ready? We're going to talk about the substitution method. All right, so for substitution, here's what you do. You find the letter that's all by itself, which usually is going to be y. You circle what it equals, and you plug it into the other equation for that variable. So since y equals 3x minus 4, I'm going to replace y with 3x minus 4. Then we're going to just solve the equation using what algebra skills we have. So I'm going to distribute the negative 8. I'm going to combine my like terms. And then I'm going to solve the two-step equation. And I get 2 for x. And the software I use, you shouldn't be ending up with fraction answers, so if you got a fraction, it's probably wrong. Not that it's impossible to get a fraction, it's just that the software I use doesn't usually generate those kinds of questions. All right. Do you guys remember what to do at this point?
Yeah.
Hey, whoa.
You go back to one of your original equations, and you plug 2 in for the x. Okay? Now, it doesn't matter technically which one you use. However, if you want it to be easier, you're going to pick the one that has the y by itself already. So that's what I'm going to do. So I'm going to take this equation, and I'm going to replace the what variable?
The x.
With
2.
and then we're good to go. So that's what we call the substitution method, because you're substituting. So in other words, if I were to graph these two lines and find where they cross, they would cross at the point 2, 2.
I don't know why I love the substitution elimination. You shut up.
Damn. Why is everyone so hostile in this class?
Okay, so we're going to do another problem here, guys. Quiet, please. All right, so we're going to do another one, but the outcome is interesting. So let's look at the outcome. So first of all, find our lonely letter, right? Circle what it equals. Plug it into the other equation for that variable. So now I've got 2x minus that. All right, so we need to distribute this negative first of all. Now these two, what's 2x take away 2x? It's 0. So those are gone. The x's are gone. And this is what I have. Now, when this happens, when there's no more x's left, something's wrong. That means either one of two things. It either means there's no solutions or there's infinitely many solutions. Do you guys know which one this would be? Infinite. Because it's a true statement. Isn't that a true statement? Okay, so if you got something weird though, like 4 equals 12, then you would say no solution. But if you get a true statement, then we say there's infinite solutions. Okay, so I'm going to let you guys work on 6 and 8 right now for a little bit. Go as far as you can.
Can I walk us through this one?
No, I have to teach it. It's a control issue. All right, so we're going to demonstrate to you guys a new method.
We've known this.
Well, okay, new today. And it's the elimination method. So we're going to use elimination to solve for x and y, okay? Now,
don't you put parentheses on both sides?
doesn't matter. So here's how I'm going to teach. Some of you guys can do this like in a very creative way to keep your numbers smaller. I leave that to you, but I kind of just teach it one way so that it always works and you don't have to struggle too much. For instance, so the first thing you guys are going to do for this is you're going to pick a variable.
Didn't we already learn this?
Yeah, this is all review. We've learned all this stuff. We're just reviewing for our final. So, Hannah, pick a variable, x or y.
Me?
Mm-hmm.
X.
Okay, so the one that she picked is the one that we're going to cancel out. Okay? So what we're going to do now is I'm going to call this step flip and distribute. Okay? So I'm going to take the coefficients for these. What are my coefficients? -9 and 8. I'm going to flip them over. So I'm going to put the -9 here and the 8 up here. I'm flipping them. And then I'm going to distribute them into the equation. Now, unfortunately, you might end up with some pretty big numbers sometimes doing it this way, but it always works. That's the good news. So, here we go. That gives me the following. 8 times -9 is -72x. 8 times -9 is also -72x. And 8 times -9 is still -72. I understand that, but I said some of you guys know faster ways, and I said that's not how I'm going to do it. You might be doing it different than me. This is mine.
That's still good, right?
Yeah. All right.
Wait, why did you numbers against it?
Why do I need what?
Another parenthesis.
Do we have to do -9 on the bottom?
One question at a time here. So, Hannah, I'm rewriting the system as it's been multiplied. So it's
Put it in parentheses again?
yeah. And then Michael, you asked a question.
Yeah.
What's up?
Is it really supposed to be -9 on the bottom? Or should it just be like positive?
You could do +9 if you have some foresight. Yeah. All right. So I'm going to multiply -9 in here. That's going to give me -72x minus 54y, and then that I don't know the answer to, so I got to multiply it. How much? 144. Excuse me, I'll be right back.
Negative? Or negative?
Okay. All right, you. All right. Now, the purpose of those first two steps, Hannah. The purpose of those first two steps, you guys, was to get two of my terms to be exactly the same. You guys see how these match exactly now? So the next thing that we're going to do is I'm going to get them to be opposite signs. So I'm going to multiply one of the equations by a -1. Okay? So now I'm going to put a -1 out here. I'm going to multiply that in. The top is not going to change because I'm not doing anything to the top. The bottom, all the signs are going to change. The bottom is positive, positive, oops, and positive. So by doing that now, these two things are now opposites. Pay attention over here. We're up here. So when you do this,
Hang on.
the purpose of doing that is so that when I add these together, those x's will cancel out. And that's my next step, is to add down. So, -72 and +72 cancel. -72 and 54, I'm not sure what that is. Let me see. It says -18 on my calculator. I'm pretty sure this one will be 72. All right? And then from there, it's easy to solve, right? So step 5 is just solve. So if I divide both sides by -18, we're good to go. Yeah. Nice job. And then once again, what do you think we're going to do at this point, guys?
Find it.
You're gonna plug that into
I'll plug in.
another equation. To get your y.
Or plug, yeah.
Good. Plug it in so you can solve for your other variable. So I'm going to show my work for that over here. What variable did I just solve for? Y. So I'm going to replace the y with -4.
We have to do for both.
Nope, just one of them.
Oh, I would do for the positive one, yeah.
Yeah, it doesn't matter which one you pick. You'll get the same answer either way. And that's what we call the elimination method. Okay? You might want to title that, I don't know. It doesn't matter. It's in the directions, but that's the elimination method. So there's 3 ways to solve a system: graphing, elimination, and substitution. Okay? Pause the video here real quick.